The U.S. Army wants to test an active electronically scanned array, AESA, radar on its AH-64 Apache attack helicopter V6 version, using a standard Apache weapons pylon. A radar of this kind would be a very valuable tool for spotting, tracking, and engaging targets, especially in bad weather and at extended ranges, including airborne threats, but it would also be able to perform more general intelligence gathering and provide improved situational awareness, along with other functions. AESA radars offer notable advantages over legacy radars when it comes to detecting one-way attack munitions and other smaller, kamikaze drones. Above all, AESA radars are typically able to spot objects of interest, even small ones and those with low radar cross-sections, faster and farther away. A request for information, RFI, for the potential in-flight demonstration of the radar on an AH-64 Apache attack helicopter V6 version was published by the U.S. government recently. Specifically, the project manager for Apache attack helicopter is conducting market research into potential sources that could provide a suitable radar. Then, a demonstration would be conducted at Redstone Arsenal, Alabama, using the latest AH-64 Apache attack helicopter V6 version. Potentially, more than one vendor might end up being selected for an in-flight demonstration of their system. Furthermore, the RFI states, the Army is also looking for responses from companies not yet able to integrate AESA radar onto a surrogate aircraft, and these are encouraged to highlight technical maturity limitations and other feasible demonstration capabilities. As for the planned scope of the AH-64 Apache attack helicopter V6 version demonstration, this will see the AESA radar used to collect data against relevant targets at various ranges. Targets will be stationary and moving and will be on land, motorcycle, truck, and tank, in a literal environment, and airborne. The proposed scenario for the in-flight demonstration includes attack profiles for ground, air, and literal targeting, a map of the Earth, NOE, route for terrain mapping, TM, TF, and TA, a DVE landing profile to preview pilotated symbology, and an overwater route for shoreline/synthetic aperture radar, SAR, mapping. Most fundamentally, an AESA radar differs from a more traditional radar in that it uses a matrix formed of hundreds of very small radar modules that are used to steer an electronic beam, instead of the radar antenna physically moving to point at a target. This makes AESAs far more reliable than mechanically scanned types, and they can benefit from better range, fidelity, and resistance to electronic warfare, and can do multiple tasks from sensing to electronic attack to communications. The beam in an AESA radar can be moved around and modulated much more quickly, which also allows the radar to conduct multiple tasks simultaneously. In the Army demonstration, for example, this might involve surveilling a battlefield for targets on the ground and in the air, as well as monitoring weather along the AH-64 Apache attack helicopter V6 version flight path. The inclusion of drone targets in the test campaign is interesting, as this is a growing area of interest for the Army and the AH-64 community in particular. As Army with AH-64 Apache attack helicopter V6 version are now practicing to refine their ability to detect and destroy enemy aerial drones, including while forward deployed to the Middle East. At the same time, AESA radars offer notable advantages over legacy radars when it comes to detecting one-way attack munitions and other smaller, kamikaze drones. Above all, AESA radars are typically able to spot objects of interest, even small ones and those with low radar cross-sections, faster and farther away. The U.S. Army's decision to test an AESA radar on the AH-64 is also interesting in light of plans to modernize AH-64 attack helicopter. For now, it is not clear what options might be pitched for the AESA demonstration, but it's certainly significant that 4 decades after the AH-64 first entered service, the Army is now looking seriously at introducing a new type of radar that promises to add major new capabilities in a variety of environments, for both targeting and navigation functions. Thanks for watching.